Good evening, sir.
Yeah, good evening. Good evening, Moksha.
Good evening, sir.
Yeah, good evening. Okay, so in the last class, what we had done? Anyone remember what we had done in the last class? Mhm.
Good evening, sir.
Yeah, good evening. So today we have our physics class, and in physics, how much have we completed? Is anyone able to recall how much we have completed in physics?
Sir, I was absent. Last week, last Tuesday, I was absent.
Okay, no issues. Mm. We had finished with human eye and the colorful world. Today we'll be again doing with electricity. So let's start with electricity. So just let me see. And may I request all of you to keep your cameras on. So however, the kids of grade 10, they are very good. They are responsible. I know, but still it would be better if all of you keep your camera on. In case you are facing any problem in turning on the camera, inform it. Also, while once the class is started, and suppose if you have some work, you need to leave the class. So don't just leave like that. Inform and then leave. Okay, it's always better. It's always better to inform and then. Got it? Okay. So anyone having any doubts in the previous chapters? Like you have, we have done the chapter light, we have done the chapter human eye and colorful world. So is there anyone who is having doubts in those chapters?
No, sir.
Sir, I don't have any doubts, but I want. Can you just keep revision classes for those, as I have my exam on Tuesday.
Okay, you have your exam on Tuesday. Yeah. See, one thing, I think most of you are having your exam. Most of you might be having your exam from 15th or 20th of July. Almost all the staff exam schools will be starting with their PA exams from 15th of July. Okay. Some of them may start from 20th or 22nd. So I think it would be better to carry on with the revision. All right. So we'll okay, that's a good suggestion. I think we shall carry with the revision starting from the chapter light. Okay, just hold for 1 minute.
Sir?
Okay, so let's continue now. Yeah, anyone having any problem?
Sir, I had a doubt, sir. It's from light,
Mhm.
refraction.
Okay,
Like, what's the difference between density and optical density?
okay. So let's see the density, what is density, and then we'll see what is optical density. See, one we hear about the mass density. Okay. The mass density of a substance, it depends on how close the matter is present in that, right? Mass density, it is determined by, it is the mass per unit volume, right? So the
Yes, sir.
mass per unit volume, it is called as the mass density, and it depends on, so it depends on the mass per unit volume. It depends on how close the matter over there is present in it. Since mass is a measure of the matter, so the closer the matter is present, it will have the higher mass density. For example, we can call here density of iron is higher than wood, right? So the density of iron is higher than wood, that we call as the mass density. This we are talking of the mass density of the substance. Then when we talk of optical density, see optical density, it means how light finds the medium. Does the light find the medium to be rarer, or does the light find it to be a denser?
Sir, what?
So the way light finds it denser or rarer, that means if the light is traveling faster in that medium, so that medium will be termed as optically rarer medium. And if light travels with a slower speed, so it is called as optically denser medium.
Oh, yes, sir, like got it. For
Okay.
light, whatever density is like easier, then it's like optical density. Like you
Yes.
describe rarer
So
medium and denser medium.
yeah, once we check the speed of light, and then we tell whether it's optically denser or optically rarer. Got it?
Okay, sir, got it.
Okay. So optical density, I can write it if the speed of light is less, so it is a rarer medium. It is a denser medium. Okay? And if the speed of light is greater, so it is a rarer medium. Now understood what does the optical density means? Optical density does not only depend on matter, it depends on how the matter is arranged. Okay? It depends on the structure of the molecules, how each of the atom has been attached to each molecule. Okay. So these are the different factors on which the optical density. That is what the difference is there between both of them. Any other doubts that any one of you are having?
Sir,
Yes.
sir, so air has highest optical density.
Air has the least optical density is for vacuum. Then after that you have air.
Okay, so denser mediums they have more optical density.
Yes. Denser medium. That denser medium, or if say speed is less, so the density will be high. If the speed is more, so density will be low. Okay. And if you talk of the maximum speed that the light can have, so the maximum speed that the light can have is 3 times 10 to the power 8. That's the maximum speed the light can have. Got it? Okay. I don't think that you have any of the doubts over here. So let's continue with a quick revision from the chapter light.
Sir,
Hmm.
sir, refractive index is inversely proportional to optical density, right?
Yeah, refractive index is directly proportional to the optical density. You can say that the optical density of a substance represents, or the optical density of a substance is represented by the refractive index of the material. Just going a little bit ahead with the, I think some of you may be facing problems with the relative refractive index. This is one of the doubts. I think what I expect that most of you might be facing a problem with this relative refractive index. Otherwise, everyone is complete about the absolute refractive index. Okay. So, relative refractive index the refractive index of a medium of a medium with respect to the refractive index of a medium with respect to another medium. So here the second medium need not be air. So such refractive index we call as the relative refractive index. The refractive index of a medium with respect to another medium is called as the relative refractive index of that medium. And the relative refractive index is represented by this formula. The relative refractive index, like suppose if you have these two medium, let's say this is your medium 1 and this is medium 2. Suppose the absolute refractive index of this medium 1 is written as N1 and it is equal to C by V1. The absolute refractive index of medium 1 is given by C by V1, where V1 is the speed of light in medium 1 and C is the speed of light in vacuum. So the the absolute refractive index of the medium 1 is given like this. Now, suppose the absolute refractive index of the medium 2, N2, is given by C over V2. So the absolute refractive index N2 is given by C over V2. And again, V2 is the speed of light in the medium 2 with respect and N1 and N2. So N1 is the refractive index of medium 1, N2 is the refractive index of medium 2. Now suppose we want to find out the refractive index of medium 2 with respect to 1. So we have written over here, it means refractive index of medium 1 with respect to vacuum. I've written N2, it means refractive index of medium 2 with respect to vacuum. So now the new symbol, it can be written like this, N21. N21 means refractive index of medium 2 with respect to 1. Some of the books they write it like this also, N2 and here they write 1. So you can say refractive index of medium 2 with respect to 1. Okay. So see, this can be written as, if I use the formula or the definition of refractive index. So by the definition of refractive index, it can be written as V1 by V2. On the numerator, we write the speed of light where we have incident ray, and on the denominator we write where we have the refracted ray, speed of the refracted ray, and this is the speed of the incident ray. Okay. So these are the two refractive indices, and hence we can obtain the refractive index of medium 2 with respect to medium 1. Now, if I want to obtain this ratio V1 by V2, so I must divide N2 by N1. So if I divide here N2 by N1, let's say N2 by N1, so it should be equal to C by V2 divided by C by V1. So C and C cancel, and you have this as V1 by V2. So the refractive index of medium 2 with respect to 1 is given as refractive index of medium 2 divided by the refractive index of medium 1. So in whatever way or whatever analogy you can use different analogies to determine that which density will be there on the top and which density will be there on the bottom. Okay. So we write it as N2 by N1 or V1 by V2. Okay. So refractive index of medium 2 with respect to 1. Everyone got the formula? Everyone must note down this formula, refractive index of refractive index of medium 2 with respect to 1 is N2 by N1, and this N2 by N1 can also be written as V1 by V2. So where, see, if you use the refractive index, you will be using this one. If you use the velocities, you will be using the formula V1 by. Anyone having any doubt in this?
No, sir.
Okay, so let us try to find out some questions over here. Let's try to do some questions with this and get perfect with all this. So I expect that all of you are ready with your notebook and pen. So be ready with your notebook and pen. Of glass is three by 2 and absolute refractive index of water is 4 by 3. Find refractive index of water with glass. Refractive index of glass with water. Okay, find these out.
The speed of light and air is 3 into 10 to the power 8, right?
Yeah. Okay, try to find these all. I'm waiting for your replies. You can send your replies in the chat, or if you know, you can speak up your answers also. So these are some of the questions.
Sir, first two answers I got, sir.
Okay, so Kashvi has sent the answer, and it's I'm waiting for your answer. Bhavna, Bhavna,
Sir. Yes, sir.
so did you get the answer for the first one? Refractive index of water with glass.
No, sir, I'm doing it.
Okay, so I think once you have understood, so it doesn't take much time to do the questions. Okay. Shall I show you
Okay,
the
sir.
formula again? I'm sharing with you the previous page so that you can take the help of the formula. So here you have all the formulas. The formula of the refractive index. You can take help from here.
Sir, what do we do for the third one?
Yeah.
Like the formula for third one.
You still have doubt with the formula?
Sir, do we use the
Yes, sir.
same formula for the third one?
Yes, you have to use these formulas. These are the formulas which are given. You'll
So
be
the
able to
third
do
question, sir.
for the third question. Okay. Think of it. Think of it if you can think of any formula. Okay, just wait for 1 minute. Till then do it. Just wait for 1 minute. I'm coming. Okay, I'm back. If you have done your questions. Okay, anyone who has obtained the answer for the first one. Pranaya, what's your answer for the first one?
Sir, I got 9/8.
For the first one.
No, for the second one, I got 9/8.
Okay. Okay, so see for the first one, it's pretty simple. You have to find refractive index of water with glass. So we write it refractive index of water with glass. Since we are finding refractive index of water, so the formula will be refractive index of water divided by refractive index of glass. Okay. So refractive index of water is 3/2. So refractive index of water is 4/3. And 4/3 divided by water is 4/3. So 4/3 divided by refractive index of glass, which is 3/2. So you get 8/9 for the first one. First one is 8/9. The second one, it will be the reciprocal of it. So it will be 9/8. And for the third one, has anyone got the answer for third one?
Sir, I'm not sure, but is like the formula lambda is equals to B by F.
You have to use the formula C equal to F lambda. So C equals F lambda, where C is the speed of light, F is the frequency, and F is the lambda or wavelength. So by using this, we put the value of C. We put C as 3 times 10 to the power 8 equals to F multiply wavelength, which is 500 multiply 10 to the power minus 9 meter. It's nano, so you have to put it 10 to the power minus 9 meter. That's the wavelength. Then the frequency would be given by 3 multiply 10 to the power 8 divided by 500 multiply 10 to the power minus 9. So this will go to the numerator. You will get 3 upon 500
Sir,
multiply.
15 into 10 power 13, sir.
Okay, let me see. So you will get here, third, this would be equal to, if I take out its here 3 zeros, so it will become multiply 10 to the power 14 divided by 500. So the 2 zeros cancel. So divide this, it's 6 multiply 10 to the power 14 hertz as the frequency. So the frequency over here, or the frequency of the substance is given, frequency of the light used is 6 multiplied 10 to the power 14 hertz. Got it? Now the last question number 4. That's pretty important. Can anyone tell the answer for the fourth one? Yeah, Huria Isha.
So the wavelength will increase, but the frequency will decrease.
Okay. Bhavna, what would happen to the wavelength and frequency? Dhriti? Dhriti,
Yes, sir.
what would happen to the wavelength and frequency?
So frequency will remain same, but the wavelength will be reduced.
Yes. See, you are correct. That frequency would remain the same. In no case, the frequency of the light changes. The frequency of the light doesn't change. The frequency of light, it depends on the source from where it is emitted. So once it has been emitted out from the source, once it's emitted from the source, so then its frequency cannot change. So that is why frequency will remain the same. For the light, always the frequency remain the same. There will not be any change of the frequency once light moves from one medium to another medium. So if the light moves from one medium to another medium, or even if reflection takes place, there is no change in the frequency of light. Frequency remain the same. Since Okay, so what should happen to its wavelength when light enters in water from air? So as we know, when light enters from air to water, the speed of light decreases. And since the speed of light decreases, so the wavelength should also decrease. Okay. So the wavelength also decreases when the light enters from one medium to another medium. There is a change of wavelength of light. Anyone having any other doubts?
No, sir.
No. A few more questions. So this was from the
Sir, I'm
refractive.
writing, sir.
Okay, just one.
Sir, what if
Yes.
they gave us to find the refractive index of water with glass, but they haven't given both the values, like not the absolute refractive index? Then what?
Completed, sir.
Yeah. What you are saying? Pardon again.
Sir, if like they've asked us the refractive index of water with glass, like without giving any values, then
Yeah. So speed is not given. Refractive indices are given. Okay. So you have a long way also by which you can go. The other way is that you can take the speed of light in vacuum or air to be 3 multiplied 10 to the power 8. First, find out the speed of light in water using the refractive index. Okay. Then you can also use the absolute refractive index of glass to find out the speed of light in glass. And then use the formula of velocities.
okay, sir.
Okay.
Okay, sir.
So I think today you got a few of the new questions over here about the frequency and the wavelength. Okay. And this doubt was also like many of you had the doubt with these. Some of them at sometimes by like which one is to be divided by. So just the next one is okay. The same question given in another way. Try out this one also. Okay. So what you have to find? You have to find the ratio of okay. So try to do this question. It's again a similar question.
The refractive index means absolute refractive index, right?
Yeah.
Refractive index means absolute refractive index.
Yeah. When it's given to just refractive index, it's absolute refractive index. Okay, so what do we have to find out here? What is to be calculated? Huria, what is to be calculated? Kashvi, what do we have to calculate here?
So the ratio of the speed of light into water.
Yeah, that is what the question says. But what do we understand from it?
So we should find the speed of light in diamond so that we can calculate.
No, no. If you go that way, again, you will be going a long way. Okay, just see. The question is just playing a trick with you. If you have to find out, according to the question, you have to find out this thing. You have to find ratio of speed of light in water to the speed of light in diamond. And this is just a ratio. So can I give any name to this ratio? Can I call this ratio to be equal to the refractive index of diamond with respect to water? Just
Yes,
think.
sir.
Yes, sir.
Yes. So now you just need to find out the refractive index of diamond with water, which will just be equal to refractive index of diamond divided by refractive index of water. So that's your answer. You have 2.4 divided by 4 by 3. So you have 4 by 3. That's it. So you get 0.6 multiplied 3. That's 1.8. So a question which you are thinking will take a page approximately. Of course, you can solve it. By that method also it's correct. But what about the time that you will be consuming? Okay. So you will be consuming a lot of time. So that is why I taught this method. Okay, everyone got the answer in this way?
Yes.
Okay, how many of you thought that you can do this by other method, like first finding out the speed of light in diamond, then finding out the speed of light in water?
Sir, V means speed, no, sir.
Yes, V means speed only. Okay, speed and velocity are same till an object travels in a straight line. Okay. So everyone's doubt is clear about this question?
Yes.
Yes, sir.
Okay. So now if you have any doubts, you can share. Otherwise, if you have any question wherever you are reading, you can share in the support group. Over there, it will be answered. Okay. So by all of you, we'll see
Sir,
again in next. Yes.
sir, the next week I'm having exam, sir. The chapter is first chapter.
First chapter means
Light,
chemical reaction. Okay,
lights.
light only. Okay.
And sir, also that chemical reactions and acid and bases, like till pH, sir.
Okay. 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 Got it. So we'll try to take as much revision as it's possible. Okay. Bye all of you.
Thank you, sir. Bye, sir.
Thank you, sir.
Bye.